Hi guys, welcome to a new video on differentiation paper 2 questions under math studies. This video deals with questions of a level 4 difficulty and upper intermediate level of difficulty, and this video focuses particularly on questions that tackle parallel lines. I shall solve the two questions on the screen in front of you, and I shall begin question 1 shortly. I shall now attempt to solve May 2017 Time Zone 1 question 6. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So in A you are required to find the derivative of g of x, g dash of x, and there is your g dash in green. Next, you are told that the tangent to the graph of y equals g of x at x equals 2 is parallel to the line y equals 21x plus 7. Show that k equals 6. So parallel is a key word here, and it means that they have the same slope. So g of x and the line have the same slope. So we should try to find the slope of either one of them, and of course the slope of the line is 21 because this is y equals mx plus c. Hence, if the slope of the line is 21, then the slope of g of x is 21 at x equals 2. So if I plug 2 into g dash of x, I should get 21. So the slope is 21 because we are parallel to this line. Hence g dash equals 21 when x equals 2. Hence I shall plug 2 into g dash, getting an equation in k. Then I shall equate this equation or this expression 4k minus 3 to 21. Hence 4k minus 3 is 21. Hence k equals 6. In double I am required to find the equation of the tangent to the graph of y equals g of x at x equals 2. Give your answer in the form y equals mx plus c. So we want the equation of a tangent. We need the slope and a point. The slope obviously is the value of g dash when x equals 2, which I know is 21. So this is the slope. Next, I need a point, so the point is obtained by x equals 2 and y equals g of 2, so I just need to find g of 2. There is our slope, there is our point. Using the GDC, I can tell that g of 2 equals 7. Let's see how to do that. So there is my equation, and note that I have included the 6 instead of the k. There is my window for your reference, and there is what the graph should look like. So second, trace, find value when x is 2, and the calculator tells me that y equals 7 when x equals 2. Hence g of 2 equals 7. Now that I have a point 2 and 7 and the slope 21, I plug the values into the point slope formula and I expand and simplify, getting this final equation of the tangent. Next, I need to use my answer to part A and the value of k to find the x coordinates of the stationary points, which are the maximum and the minimum. I cannot use the GDC to find them automatically. I have to show work out because they specifically said use your answer. You should know that stationary points are points where the slope is 0. Hence g dash is 0. Hence this expression is equal to 0, and this is the same as what we found in A, but with k equals 6. So I've plugged the k into the expression. I shall solve this equal to 0. We can factorize and we find that x equals negative 5 and x equals 1. Next, we are required to find g dash of -1 and hence justify that g is decreasing at x equals -1. So to get g dash of -1, I press on second, trace dy by dx -1, and the calculator tells me that the slope is -24. G dash is -24 when x is -1. The justification that g is decreasing is that the slope is negative. So since the slope is negative, hence g is decreasing. Finally, in E, I'm required to find the y coordinate of the local minimum. So second, trace minimum, there is your left bound and your right bound and your guess. So the minimum exists at 1 and -3. 0.999 is just 1, x equals 1, and y equals -3. So there are your answers. Take a minute to check them out. This concludes the question. I hope you have found this useful. I shall now tackle paper 2, November 2007, question 5. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So you are given the diagram of a curve and a line. You are told that the line L passes through points 1, 1 and 2, 3, and that the graph P has a function f of x equals x squared minus 3x minus 4. In question A, you are required to find the gradient of the line L. This has nothing to do with differentiation. You have 2 points, so you shall just use the equation of the slope, which is y2 minus y1 over x2 minus x1. So there is my equation, and the answer is 2. Next, we are asked to differentiate f of x, which is this function. So since f of x equals x squared minus 3x minus 4, f dash of x shall equal 2x minus 3. In question C, you are required to find the coordinates of the point where the tangent to P is parallel to the line L. So the key word here is parallel. If two lines are parallel, then they have the same slope. And since we already know that the slope of line L is 2, hence it is as if this question is asking us to find the coordinates of the point where the tangent has a slope of 2. So since the lines are parallel, hence the slopes are equal. Hence the slope of the line is 2, like line L. Hence I equate the equation of the slope to 2. So 2x minus 3 shall equal 2. If 2x minus 3 is 2, I do some simplification, some algebra, and I get that x equals 5 over 2. Then I substitute the 5 over 2 into the equation of the curve in order to find y. So instead of this x, I shall put 5 over 2, and instead of this x, I shall put 5 over 2, and the y is negative 5.25. Hence the point is 5 over 2 and negative 5.25. In question D, I am required to find the coordinates of the point where the tangent to P is perpendicular to the line L. So if two lines are perpendicular, then their slopes are related by the equation m1 equals negative 1 over m2. So let's take a look. So there is the equation that relates the two slopes. Since the first slope is 2, hence the second slope shall be negative half. And again I equate f dash to the new slope, so 2x minus 3 equals negative half. I solve again for x, and this is the value I obtain. Then I substitute this value into the equation of the function in order to get the value of y, and my point is this point, 5 over 4 and negative 6.1875. In question E, I am required to find the gradient of the tangent to P at the point with coordinates 2, negative 6. So to find the gradient of the tangent, I simply get f dash of x and I substitute x with the given value, which is 2. So I already have f dash of x in B, so let's take a look. There is my f dash. So I'm going to simply substitute the x value of the point into f dash. So I just need to calculate 2 times 2 minus 3, which gives me an answer of 1. Next, I need to find the equation of the tangent at this point, and in order to find the equation of a tangent, I need a point and the slope. So the point is already given and the slope has been calculated in I. So I just plug the values into the point slope formula. There is my point and there is my slope. So y plus 6 equals 1 times x minus 2. This is the equation of the tangent. So in F, I'm required to state the equation of the axis of symmetry of P, and from your knowledge of quadratics, you should know that the axis of symmetry of a quadratic function splits it into two symmetrical halves, the reflection of one another, and there are two ways to get the equation of this line. A way that you've studied under the topic of quadratics, which is negative b over 2a. X equals negative b over 2a. So since b here is negative 3, so negative b shall be positive 3. So positive 3 over 2 times a, and a is the coefficient of x squared, which is 1. So positive 3 over 2. So x equals positive 3 over 2. This is the way to get the equation of the line using quadratics. However, since we are solving on differentiation, let us note that the equation of the axis of symmetry can be obtained by realizing that the axis of symmetry passes through the minimum point. So I want the equation of the line passing through the minimum point, and we know that the minimum point exists when f dash equals 0. Hence, I equate f dash to 0, so 2x minus 3 equals 0 and x equals 3 over 2. So this is another way of obtaining the equation of the axis of symmetry, which is the vertical line passing through the minimum. Finally, I need to find the coordinates of the vertex of P and to state the gradient of the curve at this point. So we already know that this is the minimum point, hence the gradient of the curve or the gradient of the tangent to the curve is 0. So this is the solution to the second part of the question. In order to find the coordinates of the vertex, I already know that x equals 3 over 2, so I just need to plug 3 over 2 into the equation of the curve in order to find the y value. So since x equals 3 over 2, hence y equals the substitution of x with 3 over 2 into this equation. So 3 over 2 squared minus 3 times 3 over 2 minus 4, which gives me negative 6.25. Hence the coordinates of the vertex are 3 over 2 and negative 6.25. And as we mentioned, the gradient is 0 because this is a minimum point, which is a stationary point. So take a minute to write the answers down if you will. I hope you have found this video useful.